Here's a famous trick problem with logarithms. We want all values of x that satisfy log base 7 of x equals 1 over log base x of 7. Step 1. Spot the key property. For any positive a and b with a not equal to 1 and b not equal to 1, the reciprocal property says log base I of b equals 1 over log base b of a. You can see this from the change of base formula. Step 2. Apply the property directly to our equation. 1 over log base x of 7 equals log base 7 of x. So our original equation becomes log base 7 of x equals log base 7 of x, which is an identity whenever everything is defined. Step 3. Work out the domain, so we know exactly when everything is defined. For a logarithm log base b of a, the base b must be positive and not equal to 1, and the argument a must be positive. On the left side, log base 7 of x requires x greater than 0. On the right side, inside the denominator, log base x of 7 requires the base x to be positive and not 1. The argument 7 is positive, so that part is fine. Also, the denominator itself cannot be 0. Log base x of 7 equals 0 would mean 7 equals x to the 0 equals 1, which is impossible, so the denominator is never 0. Combining all conditions, x must be positive and x cannot be 1. Therefore, the complete solution set is all positive x except 1. In interval notation, open 0 to 1 union 1 to infinity.
We will solve the exponential equation step by step, with every move clear and precisely timed. The equation is 3 to the power of n plus 1 minus 3 to the power of n equals 18. Step 1. Use the exponent rule. A to the m plus k equals a to the m times a to the k. So, 3 to the n plus 1 becomes 3 to the n times 3 to the 1. Substituting that into the equation gives 3 times 3 to the n minus 3 to the n equals 18. Step 2. Factor out the common factor 3 to the n. We get 3 to the n times 3 minus 1 equals 18. Step 3. Simplify the parentheses. 3 minus 1 equals 2. So we have 2 times 3 to the n equals 18. Step 4. Isolate the exponential term by dividing both sides by 2. 3 to the n equals 9. Step 5. Write both sides with the same base. 9 is 3 squared. So 3 to the n equals 3 squared. Step 6. Because the bases match and are positive and not equal to 1, the exponents must be equal. Therefore, n equals 2. Check. Substitute n equals 2. 3 to the power of 2 plus 1 minus 3 squared. That is 27 minus 9 equals 18. Verified. Final answer. N equals 2. Every step used basic exponent rules and clean algebra to isolate the power and compare exponents. This is a great problem that uses properties of logarithms. We will solve log of x plus log of 2x plus log of 3x equals 3. We will go carefully, step by step, and not skip anything. Before we combine logs, remember the domain rule. For common logarithms, the input must be positive, so x must be greater than 0. Step 1. Use the product rule. For logarithms, the sum of logs equals the log of the product, so we combine into a single log. Step 2. Multiply the factors inside the logarithm. X times 2x times 3x equals 6x cubed. So we get log of 6x cubed equals 3. Step 3. Convert the logarithmic equation to exponential form. The word log here means base 10, the common logarithm. Log base 10 of 6x cubed equals 3 means 10 to the power of 3 equals 6x cubed. Step 4. Compute 10 cubed and isolate x cubed. 10 cubed is 1000. Divide both sides by 6 to get x cubed equals 1000 over 6. Reduce the fraction to 500 over 3. Step 5. Take the cube root of both sides. So x equals the cube root of 500 over 3. This value is positive, which matches the domain requirement x greater than 0. Numerically, that is approximately 5.503. Final answer. X equals the cube root of 500 over 3. In this quick lesson, we'll solve a beautiful logarithm and exponent equation step by step with 0 skip steps. Our equation is 2 raised to log base 2 of x minus 3 equals 4 raised to log base 4 of 2x. Step 1. Focus on the right-hand side. We'll use the key identity, b to the power log base b of y equals y. Here the base is 4, and the inside is 2x, so the entire right side becomes simply 2x. Now, rewrite the whole equation with this simplification. Step 2. Now, simplify the left-hand side. Use the subtraction exponent rule. A to the power m minus n equals a to the m over a to the n. That gives 2 to the log base 2 of x divided by 2 cubed. Next, apply the same identity again. 2 to the power log base 2 of x equals x. So the left side becomes x over 8. Step 3. Substitute both simplifications into one equation and solve. We get x over 8 equals 2x. Multiply both sides by 8. That gives x equals 16x. So move x to the right to get 0 equals 15x. Divide by 15. We obtain x equals 0. Step 4. Always check the domain for logarithms. Log base 2 of x requires x greater than 0. Log base 4 of 2x requires 2x greater than 0. So again x greater than 0. Our candidate, x equals 0, does not satisfy x greater than 0. It is extraneous. Therefore, this equation has no solution. Key ideas used today: b to the power log base b of y equals y, and a to the power m minus n equals a to the m over a to the n. Always check the domain for logarithms. Evaluate without a calculator the expression log base 5 of 125 plus log base 125 of 5. We'll write the expression clearly, then handle each logarithm one at a time, and finally add the results. Step 1. Evaluate the first term, log base 5 of 125. This asks, to what power should we raise 5 to get 125? Since 125 equals 5 cubed, log base 5 of 125 equals 3. Step 2. Evaluate the second term, log base 125 of 5. We want the power p so that 125 to the p equals 5. Because 125 is 5 cubed, p must be 1/3. So log base 125 of 5 equals 1/3. Alternatively, use the reciprocal property. Log base 125 of 5 equals 1 over log base 5 of 125. Since that earlier value was 3, this equals 1/3. Step 3. Add the two values. We have 3 plus 1/3. Convert 3 to ninths over 3. 3 equals 9 over 3. Now add the numerators. 9 plus 1 equals 10, so we get 10 over 3. Therefore, the final value of the original expression is 10 over 3. Recap. Write 125 as 5 cubed. Evaluate each logarithm as 3 and 1/3. Then add to get 10 over 3. In this lesson, we will solve the logarithmic equation step by step, with each move shown on screen. The equation is log of x plus 3 plus log of 5 minus x equals log of 4. Step 1. Determine the domain. For any logarithm, its argument must be positive. From log of x plus 3, we need x plus 3 greater than 0, so x greater than -3. From log of 5 minus x, we need 5 minus x greater than 0, which means x less than 5. Therefore, the solution must lie in the open interval -3 to 5. Step 2. Combine the two logarithms using the product rule. Log of a plus log of b equals log of a times b. We apply it to the left side. That becomes log of the product. x plus 3 times 5 minus x equals log of 4. Step 3. When logarithms with the same base are equal, their arguments are equal. So we drop the logs and set the insides equal. Parenthesis x plus 3 times parenthesis 5 minus x equals 4. Step 4. Expand and rearrange into a standard quadratic. Multiply using FOIL. 5x minus x squared plus 15 minus 3x. That simplifies to negative x squared plus 2x plus 15 equals 4. Subtract 4 on both sides to get negative x squared plus 2x plus 11 equals 0. Multiply by negative 1 to make the leading term positive x squared minus 2x minus 11 equals 0. Step 5. Solve the quadratic with the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Here at equals 1. b equals negative 2, c equals negative 11. Substitute. Under the square root we get 4 plus 44, which is 48. The square root of 48 is 4 times root 3. So x equals 2 plus or minus 4 root 3, all over 2, which simplifies to 1 plus or minus 2 root 3. Step 6. Compute approximations and check the domain. The approximate values are x1 about 4.464 and x2 about minus 2.464. Both numbers are greater than negative 3, and both are less than 5. Therefore, both solutions belong to the interval negative 3 to 5 and are valid. Finally, state the solutions clearly. The solutions are x equals 1 plus 2 root 3 and x equals 1 minus 2 root 3. Welcome! In this quick lesson, we solved the logarithm equation log base a of 81 equals 4 over log base 3 of a, and we explain why it works for its whole domain. Then we'll also solve a very common alternate version that yields specific numbers. Here is the problem. We must find the value or values of a satisfying the equation. Step 1. Use the change of base formula. It says log base b of x equals log base c of x divided by log base c of b. Because the right side already uses base 3, we switch the left side to base 3. Now simplify log base 3 of 81. Since 81 equals 3 to the 4th, log base 3 of 81 equals 4. Substitute that 4 into the change of base result. We get 4 over log base 3 of on the left, which is exactly the right side. This means the equation is an identity. It is true whenever both sides are defined. Now state the domain. First, the base must be positive and not equal to 1. Second, the denominator log base 3 of a cannot be 0, which again forbids it equal to 1. Therefore, the complete solution set is all positive and not equal to 1. Many contests intend a single numeric answer. A very common intended version is log base a of 81 equals log base 3 of a. Let's also solve that quickly. Use change of base again. Let x equal log base 3 of a. Then 4 over x equals x. Multiply both sides by x squared equals 4. So x equals plus or minus 2. Convert back to a equals 3 to the x. Thus, a equals 9, or 1 over 9. Summary. The given equation is an identity by change of base, so the solution set is all positive of not equal to 1. The alternate contest style equation has the numeric answers 9 and 1/9. Great work!
We're going to find the value of the product of two logarithms. The expression is log base 4 of 64 times log base 8 of 32. We'll evaluate each logarithm separately, then multiply the results. A logarithm is an exponent. If log base b of a equals x, that means b to the power x equals a. First, evaluate log base 4 of 64. We find x such that 4 to the x equals 64. 4 to the first is 4. 4 squared is 16, and 4 cubed is 64. So log base 4 of 64 equals 3. Next, evaluate log base 8 of 32. Let y equal log base 8 of 32. That means 8 to the y equals 32. Rewrite both numbers as powers of 2. 8 is 2 cubed, and 32 is 2 to the 5th. Then 2 to the 3, y equals 2 to the 5th. So the exponents must match. 3y equals 5. Solving gives y equals 5 over 3. Finally, multiply the two values. We have 3 times 5 over 3. The 3's cancel. The product equals 5. Key idea: treat each logarithm as the exponent it asks for, rewrite numbers using a common base when helpful, and then multiply the results. That gives the clean answer of 5.
We will solve, step by step, the logarithmic equation log base 3 of open parenthesis 2x plus 1 close parenthesis equals log base 9 of open parenthesis 4x minus 5 close parenthesis. We will first make the bases the same, then solve carefully and check the domain. Step 1. Make the bases match. We will rewrite base 9 in terms of base 3. Because 9 equals 3 squared, we use the change of base ideal log base b of m equals log base a of m divided by log base of b, or when b equals a to the power k, log base a to the k of m equals 1 over k times log base o of m. Applying this with the equals 3 and k equals 2, we get log base 9 of open parenthesis 4x minus 5 close parenthesis equals 1/2 times log base 3 of open parenthesis 4x minus 5 close parenthesis. Now our equation becomes log base 3 of open parenthesis 2x plus 1 close parenthesis equals 1/2 log base 3 of open parenthesis 4x minus 5 close parenthesis. Step 2. Use the power rule of logarithms. C times log base b of m equals log base b of m to the c. So 1/2 times log base 3 of open parenthesis 4x minus 5 close parenthesis becomes log base 3 of open parenthesis 4x minus 5 close parenthesis to the 1/2. That is the square root. Therefore the equation is log base 3 of open parenthesis 2x plus 1 close parenthesis equals log base 3 of square root of open parenthesis 4x minus 5 close parenthesis. Step 3. When logs with the same base are equal, their arguments are equal. So we set 2x plus 1 equal to square root of 4x minus 5. To remove the square root, we square both sides. Left side becomes open parenthesis 2x plus 1 close parenthesis squared. Right side becomes 4x minus 5. Step 4. Solve the resulting quadratic equation carefully. Subtract 4x from both sides. Then subtract 1 from both sides. Finally divide by 4. We obtain x squared equals negative 3/2. Step 5. Interpret the result and check the domain. Since the square of any real number cannot be negative, x squared equals negative 3/2 has no real solution. But logarithms also require positive arguments. From the original equation, we must have 2x plus 1 greater than 0, so x greater than negative 1/2, and 4x minus 5 greater than 0, so x greater than 5/4. Together the domain requires x greater than 5/4, which conflicts with any non-real value. Therefore, there is no real solution. The solution set is the empty set.
In this quick lesson, we will solve the equation log base 2 of x plus log base x of 2 equals 3. Then we will present the answers clearly step by step. Step 1. State the original equation. Step 2. Use the change of base idea. The key identity is log base b of a equals 1 over log base of b. Apply it to the second term, log base x of 2. Step 3. Introduce a substitution to simplify. Let u equal log base 2 of x. Then the equation becomes u plus 1 over u equals 3. Step 4. Solve for u. Multiply both sides by u. We get u squared plus 1 equals 3u. Bring everything to one side. U squared minus 3, u plus 1 equals 0. use the quadratic formula. Step 5. Convert each u value back to x using u equals log base 2 of x. That means 2 to the u equals x. First case, u equals 3 plus square root of 5 over 2. Then x equals 2 to the power of 3 plus square root of 5 over 2. Second case, u equals 3 minus square root of 5 over 2. Then x equals 2 to the power of 3 minus square root of 5 over 2. Step 6. Domain check. For both logs to exist, x must be positive and not equal to 1. Our two values are positive powers of 2, so both are valid, and neither equals 1. Step 7. Compute useful approximations. X sub 1 is approximately 6.139. X sub 2 is approximately 1.303. Final answer. The solutions to the equation are x equals 2 to the power of 3 plus square root of 5 over 2, and x equals 2 to the power of 3 minus square root of 5 over 2.
Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem-solving tips. Let's make maths simple. One video at a time only on Myverse Maths.